Alright, now we want to look at limits. Okay, how do we limit a joint? So we're truly understanding motion here. Object, snap, cursor to selected. Oops. Snap, cursor to selected. That'll pop it right there, and that way when I add a cube, it'll be in that area. So what I want to do is make a limit on this joint, just as a study. So what's a study? A study is, you're not making anything in specific. I'm not making a robot here. I'm understanding something, and that's your first step, is the understanding of it first, because if you understand it, then you can be creative with it. To feel at ease with something, to feel comfortable about doing it, that's when you start becoming more creative using it. You use a hammer for the first time as a child, what do? You swing it and you hit something. Doesn't matter if it's a nail or an egg, you hit something, because that's what a hammer does. You know that instinctively. So almost a hammer, you can be as creative as you want right off the bat. It's the most instinctive tool ever. Because as a small child, you know you have to hit something with it. With 3D and studies, you have to study before you can apply it. Okay, so I'm going to put a limit like right here. I'm going to take this form and put it right there. So that it has a gap right in here. Okay, now we also have to start practicing about making things look better. Okay, so let's do this. Let's chip away at this first. I need to know the diameter of this, and I know it's 20 because I remember that. But if you don't remember it, just make a cylinder. Rotation on Y. Sooner or later you won't have to rotate something halfway just to know where to rotate it. You can just look at it right off the bat and say, hey, that needs to be rotated in Y. So I'm going to make a cylinder that's exactly that, or close to it. Very close. And that's 20. So I'm going to go 20.8. There we go. Now we have a nice cylinder. And now we need to match that up in our top view to our already laid out form. And you can see that gap. That gap's huge right there, right? That's a big gap. So I'm going to make this a little bit bigger. At some point you get to eyeballing it pretty good. So that's my maximum. Now what I want to do is join some forms together. So I need this form and this form to be joined. Okay? That one's cube, this one's cylinder 5. So I'm going to Boolean union cube and apply that. Okay? Now I can take the other one out and delete it so I don't get it confused. That cylinder that I made, that's called cylinder. This one's called cylinder 5. I'm going to Boolean that Boolean, this time difference of cylinder, and apply. Then I can get that one out of there. And essentially what I have here is a hinge that has a limit, but it's ugly. It's really ugly. So how can I make that look nicer? Well, I could do this cylinder, maybe 3 on the number pad. So now I can start thinking about aesthetics a little bit. This is how I think about aesthetics with the mechanical. So this looks harsh, these two forms. So what I want to do is make a knife that can cut them. So what I'll do is make the knife just a little bit bigger, like that. And then I chop off all the faces on the one side. Faces. And I'll also chop off the faces in the center, leaving me with this curve. Okay, now I'll grab all the faces and Control E them, W on the keyboard, and go this way. Alright, go to N on the keyboard, and what we're going to do is display shading backface culling. So this object right here, when I extruded it backwards. Now I can't see that. So object, apply, rotation and scale. I just want to make sure that it's not transparent. And it's not. That's good. I did a good job. Okay, make this form a little bit bigger this way. And then what I'm going to do is I'm going to use this as a cutter. So that's a lot of it is making your own custom cutters. Okay, that's cylinder. This one's cylinder 5. So I want to go Boolean, different, cylinder 5, or cylinder. And I hit apply. And once you're done with the cutter, you can delete it or keep it, but look at that. Doesn't that look nice? Yeah. Okay, here's a way to keep things flat. So here on the end, you grab all the vertices, zoom way in, and you go scaling them this way. That will flatten them all out. So the only part that we changed here was this part. So what I'm going to do is duplicate it, -180 it, or 180. Perfect. And then I'll export that as a still. And I want you to print that. Just that. In the end, we'll have a nice little collection of different examples of motion. There we go. And what I could do here is I could delete one of these, maybe minus it, and then just add a limit to it. So if I wanted to have both of them as an example, I could do that. Pretty cool. I probably already got that part printed, so I'm just going to choose not to print that one, and I'm just going to export this one. Remember not to have any support material on. Once we master the hinge, we'll go to the ball and socket and see how we can limit the ball and socket joint a little bit. What's its maximum, what's its minimum, and then we start thinking about attaching them to more of an organic structure. So that's our next thing, is actually looking at the hinge joint as a more organic thing. How do we do that? Alright, so print that, then come back to the videos.